All right, so welcome to AP Stats. This is our first lesson, and I just want to kind of introduce you to the topic of statistics. So hopefully you've been reading and you've learned that statistics is the science of data. There is an overwhelming amount of data available to us. So to help that data speak, we have to do data analysis. And data analysis is the process of organizing, displaying, summarizing, and asking questions about data. So during this class, we're going to learn how to analyze data. So the first few definitions that you really need to learn, and go ahead and learn them now because it's going to make the rest of this class much easier. But in data, we have the individuals. So these are the objects. They could be people, animals, or things, and this is described by set of data. The variable is any characteristic of an individual. And the variable can be categorical or quantitative. So the categories are kind of groups or categories, and the quantitative take on numerical values. If it makes sense to find an average or a mean of the variables, then it's quantitative. If it doesn't make sense to take an average, then more than likely it's categorical. So take a minute to copy these down in your notes. If you need to pause the video, go ahead and do so. And when you're ready to move forward, then just start it again. So we were talking about categorical and quantitative variables, and a key thing that I want to point out is that every variable that has a number value is quantitative. So think about zip code. My zip code here in Elon is 27244. If you live in Gibsonville, 27249. If you live in Burlington, 27215 or 17. So in this area, or people that go to Western could have 4 different zip codes depending on where they live. So would it make sense to take an average? If we collected everyone's zip code in our class, would it make sense to take an average of our zip code? No, it wouldn't. So this is actually a categorical variable, even though it has a numerical value. Okay, because it's talking about location. People are located in a certain area, and it would not make sense to take an average of these numbers. Another example of a variable that takes on a numerical value that is not quantitative would be area code. So our area code here is 336. In Raleigh, it's 919. In Wilmington, it's 910. If you go to the mountains, it's 864. Again, it would not make sense if we collected data on area codes to take an average of those numbers. So that would be quantitative. So don't just jump to the conclusion that it's quantitative just because you see a number. So the next definition I want you to copy down is distribution. A distribution tells us what values a variable takes and how often it takes those values. So here's an example of a distribution, and we're kind of going into more detail of what a categorical variable is. So if categorical variable places individuals into one of several groups or categories, we've already talked about that. The values of a category variable are labels for the different categories available. And the distribution is the list, it lists the count or the percent of individuals who fall into each category. So here's an example of radio stations. The format, that's the variable. Okay, the different types of format are listed right here. All right, so adult contemporary, adult standards, all the way down to other formats. These are actually the values. So these are the values that the variable takes on. The distribution would be your counts. So how many radio stations fall into the country category? It's 2,066. So it just kind of tells you how the stations are distributed throughout the different types of stations. That table is a frequency table because it is the number of counts. A relative frequency table, the one on the right side, it lists the percents of stations that fall into each category. So adult contemporary, if we were to do 1,556 out of the total 13,838, that would give us the percent 11.2. So a relative frequency gives us the percents instead of just the counts. Make sure you know the difference when you're looking at a table. Is it the counts it's giving you, or is it the percentages? Do you need to calculate the percentages? So it's always good to know what information is given and what information you need. So here's how we would display these distributions when we're working with categorical variables. The two best distributions you can draw, one is a bar graph, that's the left one, and one is a pie chart. Okay, in a bar graph, the bars should not touch. There should be spaces between them. You should always have labels. So we have it at the bottom, the labels of each of the stations, and we have the count of stations. That's kind of the left side there. And then with our pie graph, make sure you have all parts of a whole. If you don't have everything that adds up to 100%, then a pie graph wouldn't work, and you would have to do a bar graph. So the next type of data or distribution we're going to look at is called a two-way table. And this describes two different categorical variables. And so you're going to have counts in the rows and in the columns. So if you notice in my example, it says young adults by gender and chance of getting rich. So in this case, we have two variables. Since it's a two-way table, two variables. The first variable is gender. The second variable is how they answered their chances of getting rich. So one variable is listed on the side here, and one variable is listed on the top here. And that's how we get a two-way table. Now, if I asked you how many males answered there was almost no chance of them getting rich, you would go to the male column and look for the almost no chance, and where they intersect is the number. The total, how many they asked, can be found in the bottom right-hand corner. Now I'll go ahead and tell you the total columns are not always given. So if you're not given this or this, then you may have to find those totals yourself. So you would just add up 486 plus 597 to get that number here. Or you might have to add up all of these to get the number down there. But make sure when you have a two-way table, the first thing you should do is find all your totals. Once you find all your totals, you may be asked to find two different types of distributions. The first one is a marginal distribution. So this is of one of the categorical variables in a two-way table. So marginal will only ask you about one variable in your two-way table. So look at the example, and if you need to copy that definition, just pause the video. So this example says, examine the marginal distribution of chances of getting rich. So the different values that that variable takes on are listed right here under the response. So there's almost no chance, some chance, a 50-50 chance, a good chance, and almost certain. Those are the different values of chances of getting rich. So we're going to look at the total. How many people answered there's almost no chance of getting rich? So here's almost no chance. The total can be found right there. So 194 out of 4,826, 4,826. So if you type this in your calculator, we get 0.04, so 4%. So pause the video, Take a moment and I want you to try the other 4 on your own. So take a look at the numbers I got. So some chance I got 14.8%. A 50-50 chance is 29.3%. A good chance is 29.4%, and almost certain is 22.4%. Since we took the marginal distribution of all the values, if we were to add up our percentages, we should be approximately at 100%. So here's the distribution of those percentages. So almost none right here below 5%. Some chance was right there close to 15%. So we just drew the bar up to where the percentage. Notice how my bar graph is labeled. I've got each bar labeled, and then I wrote down at the bottom survey response. So that tells the whole thing about what each of those values are. And then on the left side, I have my numbers, and I labeled that those are actually percentages and not counts. So be sure when you're drawing a bar graph that you label all the parts. Take a minute, pause the video. I want you to look in your book at page 14, and I want you to go through and see if you can do the check your understanding on page 14. So the check your understanding on page 14 is actually asking you to find the marginal distribution of gender on the same data set that we just did their answers. So for females, there are total 2,367 females, and total students or people asked were 4,826. So this equals 49% female. For the males, there were 2,459, and total was still 4,826. So it was 51% male. So again, remember, for marginal distributions, you are only looking at one variable at a time. So the first example we did together, we were looking at their responses and the distribution of responses. The second one that you did on your own with the check your understanding, you were looking at the distribution of gender. So marginal distribution takes the one of the two variables and looks at its distribution by itself. The second type of distribution we're going to look at is called a conditional distribution. All right, so this is one that will actually look at both variables. So it'll look at the distribution of a value among the individuals that take on a certain value of the other variable. So the example, we're looking at the same data that we've been looking at. It says calculate the conditional distribution of opinion among males. So we're looking at distribution of opinion, but only among the males. So to do this, instead of taking our total from the total people asked, our total will come out of the males. So total males, we have 2,459. So of those males, how many answered no chance? Almost no chance. 98 did. So the conditional distribution of opinion among males, it would be 98 out of 2,459. So 4% of males answered almost no chance. For some chance, it was 286. So 286 out of 2,459 gives us 11.6%. For 50-50, it would be 720 out of 2,459, so that's 29.3%. A good chance would be 758 out of 2,459, which is 30.8%. And almost certain, is 597 out of 2,459, and that's 24.3%. So this is the conditional distribution of opinion among males. Now take a minute, and I want you to try and do the conditional distribution of opinion among females. Pause the video. So for females, the total females is 2,367. So that will be the new total you should use. So these are the numbers you should have gotten. So 4.1% of females answered almost no chance. 18% said some chance, and on down the line. If you notice, when we're doing the conditional, these add up to 100%, and these add up to 100%. But it doesn't this way. So it will add up 100% in one direction, and it could be the row instead of the column, but it's only going to be one and not the other for a conditional distribution. So here would be how we would graph this distribution. This is called a segmented bar graph. So I have a bar for males and a bar for females, and I would just shade the different answers according to their percentages. Since the whole column added up to 100%, then that whole column goes in a bar. So conditional distributions usually are represented by segmented bar graphs when you graph them. So now again, pause the video, take a minute, and I want you to do the check your understanding on page 17. You only have to answer part 1 of the check your understanding. You don't have to do question 2. So for this one, to do your conditional distribution of gender among each of the other 4 categories, you can see here I've got the 4 categories listed and I've got gender. Okay, so since it's among the other 4 categories, that's where our total will come from. So almost no chance, the total for almost no chance is 194. So the females are 96 out of 194. The males will be 98 out of 194. So the official distribution of gender among the other 4 opinions for almost no chance, the females would be 49.5%, and the males would be 50.5%. So here's the rest of the values of that conditional distribution. So again, this is gender among the 4 opinions. So typically what comes second is where your total is going to come from. That's not always the case, but for the most part it is. So just be really careful when you're reading the question that you make sure you know where the total is. Is the total coming from which variable? In this case, is it coming from the gender variable or is it coming from the opinion variable? So you can do it both ways. It just depends on what the question is asking you for. The last thing I'm going to leave you with is how to organize a statistical problem. This is a 4-step process. We're going to use this throughout the semester. But typically for the free responses, you want to do a state, plan, do, conclude. So you're going to state your question. What question are you trying to answer? Your plan is what statistical techniques will you use to answer that question. The do portion will be actually drawing your graphs and carrying out your calculations. And then your conclusion is always relating it back to the real world setting that your problem is in. So we will go over this a lot more throughout the semester, but I just wanted to go ahead and let you copy this down in your notes. I hope you enjoyed this lesson, and when we are in class, we will actually do a lot of these problems together and make sure that you guys don't have any questions. Thanks so much, and just shoot me an email if you do have questions.